Plate solving. Sounds like something chefs have to do during the lunch rush hour, but if you've ever used a C-Star, an ASI Air, or Nina, you've already done it yourself. Tonight we're going to unpack what plate solving is, why astronomers came up with it in the first place, and why it's the single feature that I believe keeps beginners from wasting entire nights not staring at anything in particular. For early astronomers, back in the day, finding your target meant star hopping with paper charts like this that would show you sort of where bright stars were and the things you were looking at, how far away they were from those bright stars. Or it meant hopping on your go-to mount and hoping that its go-to accuracy was close enough. Now at about 200 millimeters, being a degree or so off just gives you a couple extra stars off in the side. But if you're at 2000 millimeters with one of the big SCTs, that same distance off means you're basically pointing at the wrong patch of the night sky. So let's talk about where the name plate solving came from. It comes from the glass plate era. From the late 1800s to the 1950s, astronomers captured images of the night sky on these very large glass photographic plates. To figure out exactly where the plate was pointed, astronomers compared the star patterns on the plates to catalogs that they had, literally by hand. And that's how we ended up with discoveries like Pluto, because they would sort of blink these two images of the night sky together and they would see something move that shouldn't have moved, and that's how you get things like Pluto. Today, it takes about 5 seconds. So to dive in a little bit more into why they originally did it, it was actually mostly for astrometry, which is measuring precise star positions. It was for making catalogs, mapping the sky so that everyone else could have a reference, and for pointing models, which refined the accuracy. Plate solving started as measurement of what was happening in space and an identification of what was there. It was not originally intended to help people point the telescope because you were exposing these things for 50, 60 seconds. Today, the same principle is applied, but digitally. Software extracts those star positions, it builds geometric patterns, and then matches them to catalogs like Gaia. All of this happens automatically. That gives you the exact RA and declination, scale, and rotation of what it is that that image is. Think of it like a Shazam, but for the night sky. So let's talk about some of the practical uses that we use it for now. Plate solving, when you're starting your imaging session for the night, centers your target. It can help with polar alignment. It enables us to do things like take mosaics and recover our targets after meridian flips, or make sure that we're pointing at the exact same thing night after night after night. For beginners, mostly it means more data and less frustration because they're not trying to have to figure out, am I pointing at the right thing here, before they take, their first 5 or 10 minute long exposures. Plate solving has been a game changer for amateur astronomers, and it's the reason that even a $500 smart scope like the C-Star feels like magic. The technology that once built these century-long sky surveys is now the reason that a beginner can nail a galaxy image on night one without really understanding where those pointer stars are located. So next time someone says plate solving, don't think math or a chef. Think of astronomers back in the day squinting at these large glass plates over a century ago. And be glad that your laptop does it all in less than a second. Upcoming in this series of sort of astronomy terms explained and deep dive, we'll probably be talking about dithering and signal to noise ratio. Drop something in the comments if there's any specific terms that you wish we could do a deep dive in. For Deep Sky Labs, I'm Francisco. Clear skies.